Hi viewers, welcome to LMS Solution. Today we are going to see about fuel cell and battery powered BLDC motor, and this is a simulation model we developed for a fuel cell and battery powered BLDC motor. This simulation model consists of fuel cell, and then fuel cell will be connected to the common DC bus via this boost converter, and then in common DC bus we are using a battery, and also in common DC bus we are connecting the BLDC motor. Here you can see that fuel cell. Here the fuel cell rating is that current at nominal operating point is 52 amps and 24.23 volt, and maximum operating condition for that fuel cell is 100 amps at 20 volt. The nominal power rating of this fuel cell is 1.26 kilowatts at rated at 24 volt, and then it can operate maximum up to 2 kilowatt. When it operated 1.26 kilowatt, the operating voltage is 52 amps and 24 volt. When operating at maximum power point, it operated the 100 amps and 20 volt. And here you need to design this boost converter based upon this voltage, input voltage, and then DC bus voltage. Here we are going to maintain at the DC bus voltage is 48 volt. Here we are connecting with the battery at a DC bus. The nominal voltage is 48 volt and rated capacity is 200 Ah, and then initial state of charge is 50%. Based upon this power rating, maximum power rating, and then voltage across that fuel cell, and then voltage across the DC bus, we need to design this LLC value. And also here we are going to apply the maximum power point tracking concept by using P&O MPPT for fuel cell. For that we are going to measure the fuel cell parameter here. That means we are measuring the fuel cell voltage and current. It going to be processed via P&O MPPT. Here we are implemented a conventional P&O MPPT as like whatever concept you are applying in the PV system, and PV system connected with the boost converter to the DC bus. We need to control that boost converter by using via a P&O MPPT. Same kind of concept only we are implemented here. So here we need to maintain 4 parameter like initial duty cycle, maximum duty cycle, minimum duty cycle, small change in duty cycle, and then you have to calculate power, change in voltage, change in power, and then you have to initialize the previous instant voltage, power, and the duty cycle. Based upon the condition, change in power and change in voltage, you need to increment the duty cycle or decrement the duty cycle. If change in power, this condition is not true, then again you have to check the change in voltage. Based upon change in voltage, we need to increment and decrement the voltage. After calculating the duty cycle, we have to compare with the maximum to minimum duty cycle. If it is within that limit, no need to change that calculation. You have to take as it is. If suppose it not obey that maximum minimum limit, then you have to maintain the current duty cycle, which is equal to previous instant duty cycle. Here overwriting that the current duty cycle voltage and power with the previous duty cycle voltage and power. This will be keep on executing for your sample. You have to adjust the duty cycle. You have to make that fuel cell operated at the maximum power point level. Here the final output will be duty cycle. The duty cycle will be compared with the PWM generator. Here just here we will get duty cycle like this, and then it will going to be compared with the triangular or a sawtooth waveform. That will be going to generate the impulse. So this PWM impulse going to be control this IGBT of this boost converter in order to extract the maximum power from the fuel cell, as well as boost the voltage from around 24 volt to 48 volt. Here we are connected at a BLDC motor drive. This is known as voltage source inverter, and then here we are using BLDC motor with it, that means PMSM with the trapezoidal concept that going to act as a BLDC motor. And then here we are measuring the Hall sensor going to be converted into back EMF by using this AND logic based upon this truth table, and finally we are getting back EMF. Here we are converting that back EMF into the getting signal for that voltage source inverter. Just you have to compare with the 0, less than 0, greater than 0. So then we will get 6 pulses. So that 6 pulses going to be used to control this voltage source inverter. And here we are providing that torque for that BLDC motor. At the time of 0.1 second, we are changing load torque from 0 Newton meter to 2.5 Newton meter. And here we are measuring the fuel cell voltage, current, and the fuel cell power. And here we are measuring the battery voltage, battery current, and the battery source, and here we are measuring stator current of the BLDC motor, EMF, and here we are measuring the electromagnetic torque. This is speed of the BLDC motor, and this is voltage across that voltage source inverter. So this is line to line voltage of the voltage source inverter. Here you can see here that this is a fuel cell parameter, and then we have battery detail, and then we have voltage and current of the BLDC motor, then we have speed of the BLDC motor, and then we have torque of the BLDC motor. Here you can see that initially that rotor speed is maintained around 3000 rpm. That means a motor is operated to no load condition. Here you can see that electromagnetic torque is maintained 0 up to 0.1 second. That's why it maintained it to no load speed. After 0.1 second, the load torque change from 0 to 2.5. It is maintained around 2.5 Newton meters. That's why the speed of the BLDC motor maintained at a rated speed condition. And then here you can see that the fuel cell power is maximum power is 2000 watts. So P&O MPPT is try to track the maximum power. So it will be tracked at 2 seconds and maintained at 2000 watts. So during that maximum power point condition, what will be happen? Voltage will be maintained at 20 volt. The current is maintained at 100 amps. At the time of 4 seconds, we are changing the pressure of hydrogen and oxygen of the fuel cell from 1 atmospheric pressure to 0.5 atmospheric pressure. Because of that, the peak power point going to be changed. That's why the peak power point will be tracked from this point to this point because of change in pressure of the hydrogen and oxygen. Because of that, what will happen? The PV or fuel cell voltage is decreased somewhat from 20 volt. It's maintaining around here you will see maintaining around 18 volt. Then the power from the fuel cell is around 1800 watts. Here you can see this is a battery voltage, this is a battery current. Battery is keep on charging, and also the charging current level is will be decreasing, depends upon the power generation from the fuel cell. And then here you will see that this is stator current of the BLDC motor, and then this is EMF electromagnetic force. This is the possible assimilation result from this fuel cell and battery powered BLDC motor. So this is the working of this fuel cell and battery powered BLDC motor. You can use this fuel cell and battery powered BLDC motor for a electric vehicle also. When you go for implementing this concept for electric vehicle, then you need to control the speed of the motor as per the drive cycle, and then you can convert this model as a electric vehicle. We will discuss in next video how we can convert this fuel cell battery powered BLDC motor to electric vehicle model. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.